Hello, my name is Rozzi and I will present my assignment 2 project of computer application in power system, which is related to machine learning using k-nearest neighbor algorithm and k-means clustering algorithm to analyze a database from a sample power system. And I'm using Python for the language of my code. And then first we need to import the library, and we use NumPy, math, tkinter, and tkinter is for the UI. This is the code for the UI, and let's just try. Let's learn first. This is our UI, and I will discuss this. I will tell you about it later again. And this, let's go to the main part. Okay, let's go directly to our main function, which will go one by one. The first thing is we need to import the dataset, which is measurement files. We are using it as the training dataset, and then analog files as the test set. First is we need to import the data to our program, and this is our function, import data. So we know that in import data we have this attribute of the dataset, and then this is we add one by one, and we create array and table for represent the data. You will see again later. And then we initialize first the k number for the k-means clustering, which is 4, and then we analyze centroid distance and the centroid, which has 4, which has order 4 to 18. 18 is represent the number of attributes, which consists of voltage and angle, and it has 9 bus. And this distance, and this is clusters, which we will divide our every measurement to 4 clusters. And then we have data cluster, which represent of the training cluster, and then this test is represented test cluster, and this is the tolerance, and this is the random list for the initialize of the centroid. First is we are using k-means clustering. First we need to initialize. Okay, first we need to run the initialize function first, and in the function we need to make the initial centroid. We are using random function, and then we calculate the distance of every measurement to the centroids, and we are using this formula that it means a Euclidean distance, and then we find the minimum distance from this part, from these 4 k-means, from these four clusters, so we can know which group the every measurement represent. And then after that we add it to the cluster, to every cluster one by one. And then for every measurement, after we identify the which is the minimum of the index, and we edit it as and we add it to the cluster which represent the minimum distance index. Then after that we will need to calculate the centroids again. Basically, we need to find the average value of every cluster. So we are using for example, we have in the cluster 1, every component in every cluster 1 we need to sum it, and then we need to divide by the size of it to get the new centroid. And then the new centroid will be assigned to the centroid. So it will be updated to the centroids, to our centroid. And then after we found the new centroid, we will use the K-cluster algorithm. We'll run the K-clusters function, which is we need to run, which will run as long as the maximum change, or it means that the difference between the new centroids and the old centroid, if it's still bigger than tolerance, it will be running and running. In the function, we will clear first the every clusters, and then we will calculate the distance again from the new centroids using the Euclidean distance, and then we will determine the minimum index again of the Euclidean distance, and then we add it to the clusters for every clusters. And also we putting the labels for the every cluster. So for the labels, it will be determined which states the measurement in. So basically we have 4 labels. The first thing is the high load, which happen during peak hours when there is a high load, and we obtain it by using thresholds 2.9 and bigger than 2.6, which is the sum of the uh, voltage at bus 5, 7, and 9. And then for the second state we have low loads, which is during night, and its opposite of the high load which has the sum of voltage at bus 5, 7, and 9 bigger than 2.97. Okay, and then for the third one we have a shutdown of generator condition for the maintenance, which have a condition when the angle of bus 1 and bus 4 is less than 0.01, and then the angle of bus 2 and bus 8 is less than 0.01, and then the last condition is when the angle of the bus 3 and the angle difference between bus 3 and bus 6 is 0.01, and the last condition is disconnection. It happens when one of the voltage is less than 0.85. Okay, that's for the car clustering. So let's try run our program to test the k-means clustering algorithm. So this is our GUI. Need to import measurement files and then import the analog files. Then we run it. As you can see that we have times and the condition of the measurements. So we can sort it. So we have several conditions, which is shutdown, low load, high load, and then disconnect. We will tell again later. And then we going jump to the KNN algorithm. So for the KNN, we have first we just need to run the KNN algorithm, which is the first thing is we need to initialize the data storage for the clusters, and then need to find the distance between the training set to the clusters. So this is we need to run for every measurement of the test set. So this is to calculate the distance of the test set, and we are using the Euclidean distance, and then after that we store it to the cluster of nearest neighbor, and then we sorted the distance to find the smallest until the largest, and we are using nearest neighbor is about 14 neighbors. We are using this formula to find how many neighbors, and we got around 14. And then after we sort it out, and then we calculate how many different clusters. I mean, for example, if measurement, and then we analyze which is the most cluster of every objects of every objects. So in this 14, and then we analyze which is the most common of the k-nearest objects. We calculate the frequency of the k-nearest objects by calculate the frequency of each cluster, and we determine which is the most common cluster from the k-nearest objects. And then we define which the most frequency. After that we add it to the cluster of every clusters, and then we determine the label of the object, and then we can look at the results. This is for the common clustering, and then this is the result. So this is the result of k-nearest neighbor. As we can see that we have 5 measurement of disconnect, 5 measurement of low load, 5 measurement of high load, and then 5 measurement of the shutdown condition. Okay, to explain better, I will try to using spider environment, but without UI. We already write it, just need to run. Okay, so as you can see that based on the result we have 47 measurement in cluster 1, 53 in cluster 2, 51 in cluster 3, and 49 in cluster 4, which represent the high load and the low load, disconnect, shutdown and disconnection. So we can see the detail in this table for the train set. So this is the table. So this is the table for the time, and this voltage in bus bar 1, bus bar 2, bus bar 3, and then the angle 2. So we can see at the final of the column we have the condition. So as you can see, for the index one, we have condition of disconnect, and then for maybe start from the 49, we have low load, and then maybe from the hundreds until the condition is high load, and then 147 until 200 we have shutdown condition. And it's also, we can see the result in for the test set in this table. As you can see that, okay, this is the table of the test array. So this is the result. So we can see that in the test set we have 5 conditions for disconnect, which start from index 0 to 4, and then also we have low load each for 5 measurement, high load for 5 measurement, and also shutdown which has 5 measurements also. Okay, I think that is my presentation about my assignment 2. I hope you can enjoy it. Thank you.